Hi. Today we are going to start our Chapter 3 note sheet. You should have gotten this from the sub, and obviously you're watching it on the video. So this chapter, one of the key topics is called exponents. Okay? And exponents are obviously anything with a power. So like x to the third, 3 is an exponent. 2 to the fifth, 5 is an exponent. Okay? And we're going to learn all the rules involving problems that have exponents in them. So just a little review here. X to the third means x times x times x. So remember that a power means multiply. That means multiplying that number as many times as the power says. So like 2 to the fifth is really 2 times 2 times 2 times 2 times 2. Okay? So it's not 2 times 5. That would be 10. This is 2 times 2 is 4, times 2 more is 8, times 2 more is 16, times 2 more is 32. Okay, so if you just do 2 times 5, you're going to get the wrong answer. Okay. On this problem, this is called expanded form, where you write out everything that's happening. Okay, like this is expanded form. This is expanded form. So I can write this expanded form expression using exponents. So I've got 4 times 4 times 4, which is 4 to the third. And then I have 1y, 2y, 3y's, 4y's, 5y's, 6y's. So I go times y to the sixth. So this would be simplified form. This is expanded form. This is simplified form. Now, there are a number of rules involving exponents that we're going to learn how to do. The first rule is called multiplying powers. And notice we have x to the m times x to the nth. Okay? In order to multiply powers, this x has to be the same. It has to be the same letter for both things we're multiplying. And anytime you're looking at exponents, like x to the seventh, the x is called the base, okay? And the 7 is called the exponent. So we're only allowed to multiply powers when the bases are the same, okay? So like in this case, I have x to the fifth times x to the 24th. What this really means is that I have 5 x's times 24 more x's. Okay? And then think about how many x's I would have written down here. Well, I'd have 5, and then I'd have 24 more. So how many would I have total? Well, 24 plus 5 would be 29. So my answer to this is x to the 29th power. Now, you probably notice that all I really had to do was add those two exponents together. And that is the rule for multiplying powers. If you have two powers with the same base, the answer will be that base to the m plus n power. So all I have to do is add those exponents. But they must have the same base. That's crucial. So for this one, you notice I have x to the third, y to the second, x to the fifth, y to the 10th. So I have two different bases going on here. I have 2 with x and 2 with y. So you can only combine the ones that have the same base. So I can combine x to the third and x to the fifth. Using this rule, I would add the 3 and the 5 together. So that would be x to the 8th. And then the y to the second and y to the 10th, I can put those two together because they have the same base. And by using this rule, I would add the 2 and the 10 together, giving me y to the 12th. You don't have to write multiply in between these because it's understood that when you have two letters next to each other, it means x times y. So that would be your final answer. So just remember, when you have the same base, you may multiply. When you're multiplying, you can add the exponents. So that was multiplying powers. Next, we're going to do what's called dividing powers. Okay? And this means there's a power on top and a power on the bottom of a division sign. So like x to the 40th over x to the 5th. Now, if you think about what's happening here, it means I have 40 x's on top. Okay? So I have 40 x's on top, and I have 15 on the bottom. Well, every time I have x over x, that's the same as 1. So if I have 15 x's down here, I can take 15 of these x's on top, and they all become 1s. Okay? So 15 of these x's cancel with 15 of these. So if I cancel out 15 of these that have a 40 up here, that would leave me with 25, because 40 minus 15 is 25. So the answer to this is x to the 25th. So our rule when dividing powers is we subtract the top power minus the bottom power. So m minus n. So in this case, I just go 40 minus 15 is 25. Here's just a shorter example of what's happening here. If I had x squared, or I'm sorry, x to the third over x squared, what I really have here is 3 x's on top and 2 x's on the bottom. That would be written out in expanded form now. And every time I have an x and an x, I can cancel them out. So I'd be left with just x, because those would be gone. But the shortcut, instead of writing it all out and canceling, the shortcut is just go 3 minus 2 is 1. And you don't have to write that 1. Okay, it's understood that it's there if you just write x. So in this example, you'll notice I have 10x to the 12th over 5x to the 6th. Now, 10 and 5, those are not exponents. Okay, those are just numbers. So if I have numbers out front, I can just go 10 divided by 5 is 2. But then I have x to the 12th over x to the 6th. So I'm going to follow my rule of subtracting the top exponent minus the bottom. So it'd be 12 minus 6 is 6. So it'd be 2x to the 6th. So numbers out front, it's okay to divide them. But when you have powers that you're dividing, exponents, with the same base, then you just subtract the exponent. So 12 minus 6 is 6. The last rule we're going to learn today is called the power of a power. And this is when we have a base to a power, or an exponent, and then in parentheses an exponent on the outside. So we have 2 exponents. So it kind of looks like this, x to the 2nd, and then that to the 3rd. Well, what this means really is that I have 3 of these. So I have an x squared, an x squared, and an x squared, if I'm writing this out in expanded form. And then this means I have 6 x's total. So the shortcut, you probably already figured it out. The shortcut is when I have a power right outside of a power, I go 2 times 3 is 6. So the rule here is x to the m times n. So for this example, I have x to the 4th to the 5th. I would just say x to the 4 times 5, which is x to the 20th. Now for this one, this is a little trickier because there's a 2 in here, which isn't a power, it's not an exponent, okay? It's just a number. So I'm taking all of this to the 4th power. So I'm going to start off with 2 to the 4th, because I go 2 to the 4th. And then now I can use my x by power of a power rule and go, since it's x to the 3rd with a 4, it'd be 3 times 4 is 12. And I have y to the 2nd to the 4th, 2 times 4 would be 8. And then you can change 2 to the 4th to be a number, but that doesn't have a power, by going 2 times 2 times 2 times 2. So it'd be 2 times 2 is 4, times 2 is 8, times 2 is 16. So the final answer would be 16 x to the 12th, y to the 8th. You can kind of think of this like it's distribution, where this 4 has to go to everything in the parentheses. So that'd be 2 to the 4th. This one I multiply, so it's 3 times 4 is 12, and this one I'd multiply, 2 times 4 is 8. So, in conclusion, we have 3 rules. We have what we do when we have 2 powers multiplied together, and in that case you just add the exponents. I have a rule where I have exponents being divided, and the rule is you just subtract. And then we have a rule where there's a power right outside parentheses, and in that case we multiply. So one example of each one, if I had x squared times x to the 5th, that's this rule. So I add them together, so I have x to the 7th. If I had x to the 5th divided by x squared, I subtract, so 5 minus 2 is 3. And if I have x to the 5th squared, I'd multiply 5 times 2. So these are the 3 basic rules that you need to know for exponents. Now you can attempt the classwork. Show the substitute that you've completed the note sheet, and she will give you the classwork for today. When you're done with the classwork, you should move on to your Moodle homework. If you have trouble with the classwork, I've made a video of how to do that as well. So if you need help, you could watch that video and it will take you through the classwork problems. Good luck.